Hello friends, welcome to this channel. This is G Solutions. This channel finds solutions for your needs. Now let us today add two voltages expressed as functions of time. In our schematic representation, for instance, we have here a source, and this is B sub 1, and another source here. This is B sub 2. You can connect this source to series connection, and we can have a single value for this. Okay, in our recurrent analysis, we just simply add or subtract our sources. That will be dependent on the polarity arrangement. Again, if it is aiding, if the polarity is aiding, you just simply add, and if it is opposing, you just simply subtract the values. But in this case, for the alternating current, we consider the angles, and we are using here the trigonometric functions. Now, suppose the value of your B sub 1 is, the general representation is B sub M for the maximum value of your voltage. Let's say for this, since this is for the voltage 1, we put here 1 and sine. Okay, this is omega t plus beta. And for B sub 2, you have B sub M 2 sine omega t plus phi. Okay, so we are to add B sub 1 plus B sub 2. Okay, now we have a value for B sub 1. The representation is B sub M1 sine omega t plus beta, and B sub 2 is B sub M2 sine omega t plus phi. Okay, and take note that we have an identity. No, I'll write it here. So note, the identity is the sine of angle A plus angle B is equal to sine A cosine B plus cosine A sine B. Okay, so this is our identity. Now, if we are going to use this identity in our previous equation here, we just okay, let me copy B sub 1 plus B sub 2. So that will be B sub M1 sine. Okay, using now this identity, so the A here will be omega t and the B is the beta. So that will be sine omega t cosine beta. So B sub M1 will be distributed. So plus cosine omega t sine beta. Okay, so same as we have done in this first term, we do also on the second term, which is plus I'll write it here below, B sub M2 sine omega t cosine phi plus cosine omega t sine phi. Okay, so that's it. So what we should do is to distribute B sub M1, and showing to you the distribution, that will be B sub M1 multiplied here. So that will be sine omega t cosine beta plus B sub M1 cosine omega t sine beta plus distribute also B sub M2 multiplied to each term. So you have B sub M2 sine omega t cosine phi plus b sub m2 cosine omega t sine theta. Phi. Okay. So that's it. This will be the distribution. You will notice that there will be a common factor. So we look for that common factor. This one, sine omega t, and this one is sine omega t. Okay, and also cosine. So we factor out sine omega t from here. So we put in open parentheses, so that what remains is b sub m1 cosine beta, and for this part this will be b sub m2 cosine phi. Okay, and for the other one, plus we factored out cosine omega t, and what remains here is bm1, okay, sine beta, and for here what remain is bm2, okay, sine phi. Okay, so that will be the equation. Okay, now let us assign a equals to vm1, this part, this is for a, cosine beta plus b sub m2 cosine phi, and for b, letter b, we assign this one, so b sub m1 sine beta plus b sub m2 sine phi. Okay, so if we are going to substitute a and b, we can write here, instead of writing this longer term, we just write a. So this will be a sine omega t, and for this term, the other term is b. Okay, this is b cosine omega t. Okay, so that will be the value, but we can represent actually this part a and b to a right triangle. Okay, so I will be drawing here a right triangle. This is a right triangle. This will be the hypotenuse. Okay, so this will be your b, and this will be your a. Now, but by Pythagorean theorem, you can have c here, and this will be your angle. We use here theta, your new angle. Okay, considering the angles of the sources. Okay, so therefore from this Pythagorean theorem, you can look for c, and c value here will be equal to the a squared plus b squared. Okay, so our b sub 1 added to b sub 2, okay, which is a sine omega t plus b sine omega t. Okay, we can introduce here for simplification one value, which is c divided by c. Okay, so again, this is a sine omega t plus b cosine omega t. Okay, If you're going to distribute here your c denominator, your equation will be like this: c a over c sine omega t, okay, plus b over c cosine omega t. Okay, so we write it like this one, so that if we are going to locate this a over c in our Pythagorean theorem, this will be a, which is considering this angle theta, this will be the adjacent side over the hypotenuse, and adjacent side over the hypotenuse is actually your cosines, okay, or simply we write it as cosine theta as a over c, okay, and the other one is sine theta, which is b over c. So therefore we can also write this one as c, which is cosine theta sine omega t, okay, plus b over c, which is sine theta, okay, cosine omega t, okay. So therefore our b sub 1 plus b sub 2 can be written also as c, okay, this is cosine theta sine omega t sine theta, okay, cosine omega t is actually applying again the trigonometric function. This one you can write that into sine, that will be omega t plus theta. So what we have here now is the new angle, okay. So this will be the representation or the derivation in adding two voltages, considering considering that this is a function of time, okay. So I do hope and believe that you already understand where and how to solve two sources expressed at time. So thank you for watching this video.